Welcome back to Chapter 12, and we are going to work through volume of prisms and cylinders. So before we get into any of our content within the notes, before now to the right I have a few different pictures that when I think of volume, I kind of differentiate that with surface area. So before now, if you look at this glass cup, I'm filling it with water. So before now, our glass of water, we were talking about its surface area, maybe of a cylinder, but now the volume is going to be the water. So how much water can I fill in a cup? Or, we all love those Mexican popsicles that are across the street from us. So before now, we've been looking at what is the surface area of maybe the cup or the container of a popsicle, but now we are going to say how much stuff do I put inside that cup to create a popsicle. So that's kind of where we're going with it. We're not looking necessarily anymore on the outside, but what fills up that space. So the volume in our vocabulary terms is the number of cubic units contained in its interior. So now, when we put units on our problems, we are going to be in cubed units. Our first postulate, 27, is the volume of a cube, and the volume of a cube is the cube of the length of its sides. So we're going to say our volume equals our side cubed, and the couple things that I think of cubes are maybe a dice, finding the volume that the dice is, or maybe a Rubik's Cube that we've played with before. Postulate 28, volume congruence postulate. If two polyhedrons are congruent, then they have the same volume. So looking out to the side, if these two polyhedrons are congruent, then their volumes are also congruent or equal. Theorem 29 says the volume addition postulate. The volume of a solid is the sum of the volumes of its non-overlapping parts. So most of the time we'll just deal with a cube or a rectangular prism, but what if I wanted to find this volume of an ice cream cone, and yes, it has a baseball ice cream on top. I would need to find the volume of my cone on the bottom plus the volume of my circle or my on the top. So both of those will need to be added together, or if you look at the house, I have a cube on the bottom, but maybe a rectangular or a triangular prism on the top. So I would need the volume on the top plus the volume on the bottom. So that's kind of what postulate 29 is saying. Moving on to the volume of a prism, we're going to say the volume equals the base area times the height. And the same thing goes with a cylinder, other than our base now is going to be our pi r squared times rh. And again, I've wrote them to the side, which you need to make sure you write these down. Again, if you notice, they're the same equation, but depending on the shape of its base will depend on what area formula you use there. So those are what is going to change. And remember, the height is the height between both of your bases. So again, the height in your formula will be the height from base to base. All right, find the volume of a prism and cylinder. And to the left, I've wrote down a few steps. So one, find the area of one base. Then identify or find the height of the solid, and then solve. So looking at example 1, it's a right triangular prism. So the area of the base I know is a triangle, so I would take 1/2 base times height. So I would say 1 times 3 to give me a base area of 3/2 feet squared. And I know my height from base to base of my solid is 2, so I'm just going to put my base area, which we found, times 2, my height, would give me 3 feet, and then cubed. Notice that our volume units. All right, now we want to find the area of our cylinder, and our base area will now be pi r squared, finding the area of a circle. So pi times 5 squared would give us 25 pi. So that would be the base area here. Now we can, we know that this 6 meters is the height, so we can just plug it in, 25 pi. Plus my height is 6, which would give me 150 pi, or approximately 471.24. So again, the steps on the side over here will definitely help. So find the area of one base, which you might have to do some work for that. Identify or find the height of the solid, so from one base to the other, and then solve using our V equals base times, or area of a base times our height. All right. So we want to use the volume to solve for maybe our radius or maybe our height. And we know that our good information that we need to use, our volume is 1,253 cubic centimeters, and we want to find our radius, it looks like. So we're just going to plug it in. Our V is 1253 from up here. We don't know our radius, but we do know our height, so we're going to plug that in too. So we're just going to keep going down. They have divided, let's solve this first. So we would have 10 pi x squared. They've divided by 10 pi to cancel. So you have this over 10 pi. And then you will get approximately 39.88. Now remember, to get rid of that squared, you have to square root. So I have x is approximately 6.32, so my cylinder has a radius of approximately 6.23 centimeters. And that is just a length, so we don't have to square it or cube it. So understanding what you are being asked to find, and then what's the proper identification for that. Alrighty. Looking at 12.8, if two solids have the same height and the same cross section, remember we talked about that in 12.1, at every level, then they have the same volume. And that will help us out a little bit later. So just keep that in the back of your mind. So finding the volume of this cylinder right here, and remember this means not a right cylinder. So our height, kind of like an obtuse triangle, you'll find it on the outside. So really from base to base, perpendicularly, our height will be 8. That part is not included in any of the figure. So the only thing we need to really use is the height. So that principle allows us to use our theorem 12.7 to find the volume of the oblique cylinder. So we're just going to be able to use that volume equation for cylinders other than just right cylinders. So our radius now is 5. So we'll fill in the blank, and then our height, like we said, was 8 still. So solving that, we would get 200 pi, which is approximately 628.32. Before now, when we were using our surface area equations, we were only using them for right cylinders or right prisms. Now we can use this volume equation for more than just right cylinders. Alrighty. So continuing on with that, find the volume of the solid. The area of the base can be found by subtracting the area of the small circle from the area of the large circle. So they have given us our big B equation down here. So the area of the large circle has a radius of 3, so we're going to just solve our pi r squared for that. So our large circle minus our small circle, which has a radius of 1, will be 8 pi, which is approximately 25.13. So we're almost taking out that part of the circle right there. So kind of like a putting green. When you look at the green, the hole that you want the ball to go into isn't necessarily in the volume of the green, so we have to kind of take that out. Now that we have our big B, we can plug it in down here. So 25.13 times our height, so from base to base will be our height, and we get 175.91. And remember, it's cubic millimeters, so we have to make sure we are labeling correctly. Cubic millimeters. All right. So that will do it for this lesson. You can go ahead and pause it, flip it over, and do your checkpoints. If you have any questions, make sure you go ahead and ask when you return, but go back and look through those examples if you get stuck on some of your checkpoints. And make sure you complete all the information that you need to. Here is 1 and 2. And make sure all of your work is shown so you get full credit. And then here is the rest of 3 and 4 and 5. So hope you have a great day. Put your favorite summer or what you're looking forward to during the summer in the right-hand corner of your notes. Have a great day.